Okay, let's start. Uh, we are discussing chapter 11. All of you open chapter 11, page number 223 in soft copy. Okay, I hope you have opened chapter 11. Are you ready? Yes or no? Okay, so I am reading from chapter 11 now. We are starting multi-threaded programming. As we have discussed in last lecture, that multi-threaded program is completely a separate chapter which includes detailed description about threads in Java. So today we'll cover two programs, how the main thread works and how to create our own thread in Java program. For that we are starting with this chapter. I'm just reading brief about the chapter. They have written some basic theory regarding threads, then we'll check the programs also. So they've written, unlike many other computer languages, Java provides built-in support for multi-threaded programming. So as we have discussed in last lecture in the discussion session, that Java, there is a buzzword of Java which is multi-threaded programming. So a multi-threaded program contains two or more parts that can run concurrently. I hope you understood what is concurrent execution because we have already studied threads in operating system. It means at least thread basics. Each part of such program is called a thread, and each thread defines a separate path of execution. Thus, multi-threading is a specialized form of multitasking. So ultimately, threading is they are telling that threading is multitasking for a computer. And when we want to a computer to have multitasking, we have to provide that in some programming way. So for that, further I am reading, you are almost certainly acquainted with multitasking because it is supported by virtually all modern operating systems. However, there are two distinct types of multitasking. One is process based and another is thread based. So this you can note down that there are two types of multitasking possible. One is process based. This is normally done by your operating system itself, either it is Windows, Linux, or any other platform. And another is thread based that we can program by ourselves. It is important to understand that difference between the two. For most readers, process-based multitasking is the more familiar form. A process is in essence a program that is in executing. Thus, process-based multitasking is the feature that allows your computer to run two or more programs concurrently. For example, process-based multitasking enables you to run Java compiler at the same time that you are using the text editor. So right now also we are doing process-based multitasking because I am reading from my Adobe Reader. Meanwhile, I'm streaming. I'm having my YouTube open. My browser is open. So this is called process-based multitasking, where different set of processes are running concurrently. In process-based multitasking, a program is the smallest unit of the code that can be dispatched by the scheduler. So what do you mean by dispatched by the scheduler? It means it is given to the processor for execution. That is called dispatch. So here multiple programs are running right now also in your laptop, in my laptop, on YouTube. So this is called concurrent execution of programs, but this is process based multitasking. In a thread-based multitasking environment, the thread is smallest unit of dispatchable code. This means that a single platform can run two or more tasks simultaneously. For instance, a text editor can format text at the same time that is it is printing. So here it is a discussion of the same process doing two things. Again, I am repeating. Earlier, we are having two separate processes running concurrently. Here, the same process is doing two different tasks. So they have written this means that a single program can perform two or more tasks simultaneously. For instance, a text editor can format text at the same time that it is printing. as long as these two actions are being performed by two separate threads of the same process. Thus, process-based multitasking deals with big picture and thread-based multitasking handles the details. Multitasking threads requires less overhead than multitasking processes. So this is the main goal of multitasking threads because multitasking processes are overhead for the computer processor. That we'll see in detail with example also. So further they have written that processes are heavyweight tasks that require their own separate address space. I think this point we have discussed in last lecture that process have process control block and thread have thread table. So as thread is lightweight process, definitely process is heavyweight task for a computer or for a processor. Interprocess communication is expensive and limited. Context switching from one process to another process is also costly. I hope you understood what is context switching. That we'll discuss in question answer session. Either you know about context switching or not. Otherwise, we'll discuss in detail. Threads, on the other hand, are lightweight. They share the same address space and cooperatively share the same heavyweight process. So again, you need to note down this that threads are they are sharing one heavyweight process, not multiple processes. Inter-thread communication is inexpensive and context switching from one thread to the next is low cost. While Java program make use of process-based multitasking environments, process-based multitasking is not under the control of Java. However, multi-threaded multitasking is. So this also you need to note down that process-based multitasking is not controlled by Java, but we can control multi-threaded multitasking. So what do you mean by multi-threading? Multi-threading enables you to write very efficient program that make maximum use of the CPU because idle time can be kept to a minimum. This is especially important for the interactive network environment in which Java operates because idle time is common. For example, the transaction rate of data over a network is much slower than the rate at which computer can process it. I think this line you can understand that whenever we are receiving the packets from the internet, definitely it is slower than the way the processor processes the packets. So that's why even local file system resources are read and written at much slower pace than they can be processed by the CPU. It means your CPU is far more faster than whatever you are receiving. And of course, user input is much slower than the computer. In a single threaded environment, your program has to wait for each of these tasks to finish before it can process to the next one. Even though CPU is sitting idle most of the time, multi-threading let you gain access to this idle time and put it to good use. It means we don't want that our CPU should be idle while processing something because normally the CPU will waste its time in fetching the data rather than processing. So that is the main key point of multi-threaded programming. If you have program for operating systems such as Windows, then you are already familiar with multi-threaded programming. However, the fact that Java managed thread makes multi-threading especially convenient because many of the details are handled for you. So we'll check now what is there in Java thread model. Up to now, whatever I have discussed, we'll complete this topic. After that, we'll have a question answer session. Then we'll check the practical part for many things. And all the class libraries are designed with multi-threading in mind. In fact, Java uses thread to enable the entire environment to be asynchronous. This helps reduce inefficiency by preventing the waste of CPU cycles. So I hope you can understand waste of CPU cycles with reference to your CUA subject and operating system subject. If you are having any doubts regarding this waste of CPU cycles, that we'll discuss in question answer session. The value of multi-threaded environment is best understood in contrast to its counterpart, single-threaded system, use an approach called event loop with polling. In this model, a single thread of control runs in an infinite loop, polling a single event queue to decide what to do next. Once this polling mechanism returns with, say, a signal that network file is ready to be read, then the event loop dispatch control to the appropriate event handler. This means that you are waiting, you are having a single thread of execution and you are waiting for some event to be occur. Meanwhile, you are idle. It is just like you are sitting on your chair, you are doing nothing and your WhatsApp notification rings and you are checking it. So this is called single threaded programming. You are waiting for some notification to happen and after that you process it, right? And the multi-threaded programming means at a time you are doing concurrent things with the same process. While studying, you are doing multiple things, right? Which is related with study only. So further, they've written this wastes CPU time. It can also result in one part of a program dominating the system and preventing any other events from being processed. It means only one part is executing, other processes are waiting to be executed, right? In general, in single-thread environment, when a thread blocks because it is waiting for some resource, the entire program stop running. So it means when someone is waiting for a resource, the entire computer halts. It is waiting for only one single thing to be occurred. So if such a thing is available, such thread execution, single thread execution is there, then you need to wait for each and every single event. The benefit of Java multithreading is that the main loop polling mechanism is eliminated. One thread can pause without stopping other part of your program. For example, the idle time created when a thread reads data from network or wait for user input can be utilized as well. So this is the main core part of threading. Again, I am reading. For example, the idle time created when a thread reads data from network or wait for user input can be utilized elsewhere. Threading allows animation loops to sleep for a second between each frame without causing whole system to pause. When a thread blocks in Java program, only the single thread that is blocked pauses. All other thread continue to run. So I think this is not understandable for you all, but you will understand it when we'll discuss the program. So I'm continuing the same. Thread exists in several states. So these are the states of thread. I think you studied in OS. A thread can be running. It can be ready to run. It gets CPU time. Running thread can be suspended, which is temporarily suspend its activity. A suspended thread can be resumed, allowing to pick up where it left off. A thread can be blocked when waiting for a resource. At any time, thread can be terminated, which halts the execution immediately. So these are the thread, what I can say, several states of thread. This is an important question in operating system also for your examinations. Thread priorities, that is the next topic. Java assigns to each thread a priority that determines how that thread should be treated with respect to others. So I hope you understood what is priority. We have discussed many times in class also that when you are having 5 or 6 threads, there is a priority number given to each thread. So a thread having higher priority can be executed first. So moving to next thing, which you will understand what is context switch, that we'll discuss in question answer session. So first thing is a thread can voluntarily relinquish control. It means thread is giving its control to other thread voluntarily. This is done by explicitly yielding, sleeping, or blocking or opening IO or pending IO. In this scenario, all threads are examined and the highest priority thread is ready to run is given to CPU. A thread can be preempted by a higher priority thread. In this case, a lower priority thread that does not yield the processor is simply preempted, no matter what it is doing by higher priority thread. Basically, as soon as higher priority thread wants to run, it does. This is called preemptive multitasking. Preemptive means you are taking forcibly the control from the thread. Okay. So meanwhile, I am skipping this synchronization point and message point. Synchronization, it means when multiple threads are running parallelly, you need to have some synchronize. Otherwise, one thread is reading a file, another thread is writing the same file. This may occur. That's why you need thread synchronization. And messaging means thread can pass message from one thread to another with what to do, what not to do. So that we'll discuss. On page number 226, the thread class and runnable interface they've given. So that I am reading. Then we'll check the program also. Java's multi-threading system is built upon thread class. So now we are in the programming part. So they are telling us that the Java's thread class, which is already available, and its methods are used to create threads. Its companion interface runnable, which is also used. Thread encapsulates thread of execution. Since you can't directly refer to the eternal state of running thread, you will deal with it through its proxy. The thread instance that spawned it to create a new thread, your program will either extend thread or implement runnable interface. So there are two ways of creating a thread. Either you extend the thread class or you implement the runnable interface. The thread class defines several methods. We'll check that demonstration of these methods also. The ones that will be used in this chapter are shown here. One is get name, get priority, is alive, join, run, sleep, and start. You can check the description and meaning also. So the next topic, which is covering the programming part. First, we'll complete this program, then we'll have a question answer session, so I can solve your doubts. Okay. So the main thread, when a Java program sorry, when a Java program start up, one thread being running immediately. This is usually called main thread of your program. It means whenever we run a program, one thread will be created, that is Java main thread. Because it is one that is executed when your program begins, the main thread is important for two reasons. First, it is thread from which another child thread will be spawned. Often, it must be the last thread to finish execution before it performs various shutdown actions. So there are two things. One, it will be automatically start, and all the other threads are child threads of the this parent thread. And second thing, this parent thread will end at the last, right, when the shutdown actions are performed. Although the main thread is created automatically, when your program is started, it can be controlled through a thread object. To do so, you must obtain a reference to it by calling the method current thread, which is a public static member of thread. Static thread current thread, which is a method. This method returns a reference to the thread in which it is called. Once you have reference to the main thread, you can control it just like another thread. Let's begin by reviewing the following example. So now they have given a basic example. You can run this program in your Apache NetBeans also, right? After this session. So what is there in the program? Class current thread demo. There is only a single class current thread demo having public static void main. What they are doing, they are creating object of thread class. You can check, and they are assigning a reference which is returned by this call. The call includes thread.current thread. Again, I am repeating, current thread is a public static member. That's why it should be called by the class name itself. So they are calling it by the thread class name, thread.current thread. So it is returning a reference which will be stored in T, which is reference of type thread. You know very well what is thread. It is a class used for threading. After that, they are printing the value of T, then what is assigned to T. Now you can change the name of thread. So ultimately T is the main thread because current thread means the main thread which is running right now. So this we have not created any thread. We are just printing the current thread which is available. After that, you can check how the method can be used to change the name of that thread. So what they are doing, t.set name, and they are passing the value my thread. So it will change the current thread name from something to my thread. And after that, again they are printing, after the name change, they are printing its name. Then they are having a temporary for loop which is starting from 5 ending to 1. They are having 5, 4, 3, 2, 1. As n is greater than 0, it will print the value of n. Then there is one more exciting thing about threads, thread.sleep. So you can make a thread to sleep for 1 second. This is in milliseconds. They have given 1000 milliseconds. It means 1 second. So they are handling it. One exception they have handled, that is interrupt exception. It means while the thread is running, if there is an interrupt, it will print main thread interrupted. So after that, they have written a paragraph in this program, a reference to current thread. The main thread in this case is obtained by calling current thread method. And this reference is stored in a local variable T. Why they are calling it local variable? Because thread is a class and T is a variable of type class. Next, the program displays the information about the thread. The program then calls setName to change the internal name of the thread. Information about thread is then redisplayed. Next, a loop countdown from 5 per pausing 1 second between each line. The pause is accomplished by the sleep method. The argument to sleep specifies delay period in millisecond. Notice the try catch block around this loop. The sleep method in thread might throw an interrupted exception. This would happen if some other thread wanted to interrupt this sleeping one. This example just prints a message if it gets interrupted. In a real program, you would need to handle this differently. Here is the output of the program generated by this program. Current thread. So earlier the name of the thread is main. you can check thread in bracket. They have written main, phi, and main. After the name change, thread, you can check the main will be changed by my thread that we have written in that particular method calling t.setName my thread, phi and main. Now what is phi? Okay, so that also we will discuss that what is the meaning of value phi. So they've written here, notice the output produced when t is used as an argument to println. This displays in order the name of thread, its priority. So phi is priority, it means the default value of priority is phi. Why it is phi, that we'll discuss. The name of its group, it means which group it belongs. So it belongs to the main group. So it means name of thread, priority, and its group name. By default, the name of the main thread is main, its priority is phi, which is the default value, and main is also the name of group of threads to which the thread belongs. The thread group is data structure that controls the state of collection of threads as whole. After the name of thread is changed in output, this time the new name is printed that we have checked. Printed the values using two methods. One is we are just printing the values, and then we are changing the value by set name. Again, we have checked one more method, that is slip. So now I'm moving to the comment section. If you're having any doubts, then you can ask me. Any doubts? If you are having any queries, you can ask. Okay, so there is a question from Zil. Waste of CPU cycles, you are not able to understand. Okay. Okay, please repeat the program parts. So I believe there, as this is a video, you can repeat the video later on. You can check that what I am explaining in the program part. This will be a good solution. You can replay the video for that. Do you know? So okay, there is a one question that I want to ask. Do you know about context switch? What do you mean by context switch between threads or between processes? Any answers regarding context switch? Handling CPU from one process to another, saving and restoring the content. Okay, anyone else? Do you know what is context switch? Context switch means moving from one process to another and again returning back to the before process by saving its address. Okay. So basically you need to understand for threads what is context switch. Context switch, it means whenever CPU is executing a process and CPU wants to transfer the control of that process from that process to another process. Okay, so someone has written, Zeal is writing that when a higher priority process comes, it switches to another. Yes, correct. So when the higher priority process is there, right, interrupt may occur or the CPU will transfer its control. It means it will take another execution. It is just like whenever you are minimizing your browser session, you are starting a new program. So at that time, CPU will context switch its execution from that particular execution to another execution. Or whenever you are shifting or you are changing your tabs in the same browser, right, that is a thread because same process is handling all the tabs. So that is multi-threading, right? You are for each step there is one thread and it is the part of the same process. But if you stop your browser or if you minimize your browser and you start some other program like Word, then you will minimize your Word, you will start another program like a game, then this is called context switch of processes. That is called multiprocessing. But within the same process like browser, you are starting new tabs, then it is multi-threading. I hope you all are able to understand this thing. So up to now, whatever I have explained, is there any doubt? Is it understandable? Yes or no? You are having a problem with the program, then what you can do, you can replay my video and you can check out that what is there in the program again. And still, if you are having doubt, we will repeat it in the next session also. Okay, so I hope some people are able to understand it. Okay, so let's move to the next part. So now we'll create our own thread, how it is created. Now this is somewhat tricky, so I want your attention in the lecture that how the thread is manually created by us through programming. We'll repeat that program and then we'll conclude the session. Given on page number 228, I am moving to creating a thread part. That is on page number 228 itself, creating a thread. In the most general sense, you create a thread by instantiating an object of type thread. Java defines two ways in which this can be accomplished. So this is the most important topic for your exams also, because many times it is asked that explain the ways of creating a thread in Java, or it may be an interview question that how you can create thread in Java. So there are two ways of creating thread in Java. One is you can implement runnable interface. This already we have discussed, and you can extend the thread class itself. So there are two ways of creating thread in Java. One is extending the runnable interface, or implementing the runnable interface, and extending the thread class. Okay. So we'll discuss implementing the runnable interface today. What do you mean by implementing an interface that we have discussed earlier when we are discussing interfaces? The easiest way to create a thread is to create a class that implements the runnable interface. Okay, so we are going to create a new class and we'll implement the runnable interface inside it. Runnable abstracts a unit of executable code. You can construct a thread on any object that implements runnable. To implement runnable, a class need only implement a single method called run, which is declared like this. It means class is going to implement a single method which is run. Inside run, we will define the code that constitutes the new thread. It means how the new thread will be created. That code is written in run. Why it is written in run, that we will discuss. It is important to understand that run can call other methods, use other classes, and declare variables just like main thread can. The only difference is that run establishes the entry point for another concurrent thread of execution within your program. This thread will end when run returns. After you create, on the next page I'm reading, after you create a class that implements runnable, you will instantiate an object of type thread from which that class, from within that class. Thread defines several constructors. The one that we will use is shown here. So there is a constructor. You can understand what is constructor. This is predefined constructor as thread is predefined class. So it includes two arguments. One is runnable thread object. It means object of type runnable interface, and string thread name. You know very well that we cannot create object of an interface, but we can have a reference of interface. In this constructor, thread_ob is an instance of a class that implements runnable interface. So we'll check that why thread_ob is instance of a class that implements runnable interface. This defines where execution of thread will begin. The name of the new thread is specified by thread name. So you can give name to the thread by thread name. So there are the two arguments of constructor of thread class. After the new thread is created, it will not start running until you call its start method. which is declared within thread. It means it is already declared in thread. You just need to call it. In essence, start executes a call to run. So now you need to understand this complicated thing, that you are ultimately calling a start method, which will automatically execute a call to run method. The start method is shown here, void start. Now we'll check the program. I hope that by the program you are able to understand. This program is somewhat tricky, so please pay your attention what is happening in the program. So we are starting with class new thread. Your name of class is new thread, which is implementing runnable. Now we are creating an instance, or you can say just reference of a thread class, which is T. Now you can check we are having constructor new thread of class new thread, inside which you are writing T, which is already created earlier, thread T is equal to new thread. It means you are calling constructor of thread. You are passing two things. This, it means, what do you mean by this? Here, this means whenever you will call the constructor, it means whenever the object of new thread class is created, that object will be passed here. And the name of thread they have given demo thread. So this is the constructor that we have discussed earlier. One is object we need to pass, calling object, and second is name of the thread that we want to create. Again, I am repeating this portion. We are having a new thread class, implements runnable interface. You are having a thread T, which is a reference of type thread. Then we are having constructor new thread, right? What we are writing, T is equal to new thread. It means we are calling constructor of thread and we are passing this. So this, it means the calling object as it is written inside a constructor which is new thread. So whenever object of new thread is created, that object will be passed here, and they have written name of thread. After that, what they are doing, they are printing like child thread, as it will be child thread of the main thread that we have discussed earlier. Main thread will be automatically created. So the child thread plus T, and then they are writing T dot start. As we have just discussed, that whenever you will write, you will call start method of thread class, it will call the run method. So here the run method will be called automatically, and from now onwards, whenever you are calling the start method, it will automatically call the run method in all the programs. So there is no way of writing or calling the run method manually. So nowhere written how to call the run method. Whenever you are calling the start method, it will automatically call the run method. Okay. So in public void run, what you are doing, you are having try, right? In try case, they have written loop again 520, and they are printing child thread I, and thread dot sleep 500. It means for half of a second, the thread will sleep and it will print the values like 5, 4, 3, 2, 1. And interrupt execution, they are printing again. If interrupted exception is thread demo, what they are doing now, they have simply written new thread. It means what they are doing, they are calling the constructor of new thread class. They are not assigning the values to anyone. It means whenever the constructor is called, the object by default, the calling object will be this. It will be used by this. So that's why they have passed this in the argument section of new thread class. So it will assign the thread value to T when this new thread is executed, creating a new thread. After that, when the thread is created, system.out.println will execute it. It will print child thread, its name, that is demo thread. Everything will be printed. T.start will call the run method. It will run the thread. It will start printing 0 by the half of the second delay. After that, when the execution returns to the main, what will happen? It will also print the main thread by 0 by the same way 5, 4, 3, 2, 1. Each time you can check the label, again the value, either it is from main thread or from the child thread. And if the main thread is interrupted, again it will print that main thread interrupted and main thread existing. This program, again I am telling that this program will be executed differently on each system depending on your processor speed, right? And you will get the different output. So without discussing the output, I will leave up to you that you will execute this program after the session. You can check what is exactly happening in this program. Now, if you are having any doubts in the program, we'll discuss in the comment section. So you have seen two programs today. One is to how to print the value of main thread, which is automatically there whenever you are running a single program. And then we have manually created a thread, which is a quite complicated program, but you need to understand it. Okay, why we are using sleep? That's Snehal is asking. So thread execution is that much faster that you are not able to uh, view the difference. Whenever we are printing the value, it will print the values like 5, 4, 3, 2, 1. So that's why, meanwhile, to allow the context switch between the main thread and the other thread, we are having the sleep. You can check that main thread is sleeping for a longer time while the child thread is sleeping for shorter time. That is half of the second while the main thread is sleeping for 1 second. I hope you are able to understand. So this is quite interesting program. If you run the program by yourself, if you check the each and every line, I hope that you are able to understand, because this requires immediate execution of the program. So I suggest after the session, all of you run these both programs, check line by line what is happening. Now you are having Apache NetBeans, so you can run the programs in Apache NetBeans. And even I can provide a session through TeamViewer for 5 or 4 people if you are having problems with Apache NetBeans. But you need to share your TeamViewer with me. So if you are having any doubts, you can ask me, as I am now open for the question answer session, and then we'll conclude the session. And the benefit of this platform is you can multiple time you can run my video and you can repeat the session that is covered, and I hope that you are able to understand it. And I suggest more number of students, please pass my message to more number of students. There's only 15 or 14 students are attending this lecture, right? So I suggest everyone to join the sessions, as we don't know when we can resume our regular sessions. So from now onwards, every day I will cover 40 or 45-minute session for 2 or 3 topics, so we can complete our syllabus in this way easily. So if anyone is having any doubts, please ask. Feel free to ask me. I hope you are able to understand and I am audible to everyone. Okay, those who are having problems related to NetBeans, they can contact me and I will try to provide the solutions by evening through TeamViewer, or by night also. As on TeamViewer, I can handle only 1 or 2 people at a time. So one by one, I can solve the problem, provide the solutions for team that NetBeans if you are not able to run the program. But I strongly recommend that you keep on learning these things, because if you are not practicing it, you are not able to understand just by theory. Okay, so if you don't have any doubts, I'm concluding the session. Signing off. We'll meet tomorrow for the session. I will share the time and details again. Okay, the people are telling that we are not able to understand the NetBeans. So I will help you out. Even you can check Google it, that how to use how to run a simple program on NetBeans. Okay.